everyone for coming to our monthly forum. These will continue happening monthly through the spring semester after a break in January. So I hope you'll continue coming, and we'll let you know. Some of them will be in-person hybrid, and others will be online only whenever the speakers are able to come in person. That will be included in the invitation, and it's a chance to come and meet them. One other event coming up that you should consider, this will also be an in-person and hybrid event, is the dissertation defense of Hanish Kodali. That's this coming Tuesday at noon. There will be details being sent out in next week's announcements on Monday. It's already in the EpiBios calendar. If you have the Teams app installed, and you may have received an invitation from that as well.
Can you please include me in that list? I had no idea.
Yeah, me too.
Sure.
I probably won't be able to join, but if I can at least get it on my calendar, I'll do my best. Thank you.
Yes, we can add both of you to the invitation. Yeah. We should start making a list of people who want to receive invitations to the EpiBios events. It will also be in the school-wide announcement that goes out. I think it goes out on Friday tomorrow. That's on I think, I can't remember the title exactly, but telomere length as an indicator of health outcomes. So today we have, I think, a really interesting talk coming up. We have both a supervisor and doctoral student coming and doing a joint presentation of the project that they have been working on. So we have Professor Deborah Balk, Professor of Public Affairs at the Marxe School of Public and International Affairs at Brooke College, also at the Graduate Center and the CUNY Institute for Demographic Research. And then along with Professor Balk, we will be having Jenna Tipaldo, a Ph.D. candidate in environmental and planetary health sciences here at CUNY. I have to say, I really like this idea that you had of presenting the work together, and I think it's a model that I'll try to replicate with other doctoral students as they come to present their research. So I left this completely up to them how to organize the presentation. So I'm looking forward to seeing what happens, and I will pass it over to you two.
Great. Sure. Sort of. So just so you know, we like doing this together as well. We have the first part of it is as you'll learn, is a paper that Jenna and I and our colleague Lori Hunter put together over the course of many Zoom type meetings and so forth. And so, and different kinds of engagements. And so the first part is a framework paper. And then, beyond that, Jenna and I have had we've had many different opportunities to work together, and some on peer research projects and some on climate assessments. And so it's been a real joy to try to do these things together. And I also have to say that particularly I mean, aging is we have aging in our future, right? We're going to have new health challenges in our future, and we certainly have more climate change in our future. And I think as a person working, I mean, I've been working now for more than a couple decades in the intersection of population and climate change. And I would not be doing my job right if I was only doing it in my peer group of, of crusty old professors, so to speak. I think that it's it really, the engagement with, a scaffolded engagement across all, undergraduates, graduate students, postdocs, junior faculty. And we don't train, if you're working at the intersection of aging and climate change, or health and climate change, or lucky enough to be working at the intersection of all of those, you only get a little bit of it in your own. You have to discover it as you go. So it's even more important that we work in these teams that have bring a variety of perspectives and experiences, and at different starting points in our sort of career trajectories. So, so with that said, let's I will Yeah. So the part one is just a motivation on why we need a framework. For those of you, the paper, so Jen and I have had the privilege of giving this paper 3 different kinds of professional seminars before. We're going to give you kind of like the speed version of it right now, and then move on to 3 empirical examples that are all newer than that work. But this work has recently just come out in Nature Climate Change. That's the link below, and you are, welcome to find it. The paper, you should be able to download it within the CUNY system. And if you can't download it, you can reach out to either Jenna or me, and we can share a link with you that will, that's open source, and you can get the paper from there. So here's like the speed version of that paper. So the context for the 21st century is that, like, demographically speaking, so we will be an older planet, older communities, we will be more urban, despite, the what's happened in COVID, and maybe, as we all work in sort of empty urban office spaces, we still are an urban, we're increasingly urban. There remains, the form of urbanization may change, but we remain increasingly urban with rural decline, both in the United States and globally. And there will probably be more migration to cities and towns, and probably from climate stressed regions. The question mark is the probable. This is a really hard thing to estimate, for example, and it's a global phenomena, but with differential pacing. Now, on the climate side, we can expect a hotter planet, a stormier planet, increase in frequency and intensity and severity of storms. We can also expect more droughts, as we know. We in New York City don't think about droughts, but we're just coming out of we still are below our water, our current water levels. We have more flooding. Often the places that are drier also experience more flood. We can anticipate sea level rise increasing, and we live in a place where that's really going to be important. If you live in any of the coastal parts of our city or region, this probably you may feel this personally. And then we also know that there are uneven burdens of the impacts of climate change. Now those sort of realities interface with the data traditions when we want to study this phenomena. In the demography world, we use census data or survey data or administrative data that come at resolutions that are spatially coarse to moderate, and they come in the form of tables or polygons or points. And they come in a temporal resolution that's like annual or decadal, but not like hourly or even daily. And therefore, when we think about integrating it with climate, it becomes a challenge. We also aim for representativeness, which is not something that typically is that phenomena really is a deeply held behavioral science tradition, less so within the sort of geophysical community. On the climate side, those data come from like events, like disaster events or extreme heat events. The data are often modeled, or they are derived from satellite or station observations. These resolutions can sometimes be spatially very, very fine or coarse. It really depends. And sometimes something which is sold as a fine data set may actually have rather coarse inputs. So always important to understand what kind of the inputs. This is true in both the right and left side here. Those data are often in what's known as raster format or point format. And so if you're somebody who works in tables, a raster data set may be a little difficult, getting increasingly easier with like R tools and so forth, or Python to use a raster data set. But it's like a slightly different data tradition, and that often it makes the barriers to entry to doing work that integrates these two disparate types of data sets, really a real challenge. These data range from hourly to annual, and they aim for spatial completeness, but not necessarily representative. So again, when we try to integrate them, we get sometimes a challenge from them. I think it's going to give a couple arrows here. Yeah, so it's like a stormy situation with a bunch of as we try to make these integrations, we are always retrofitting these things. And today you'll see some examples of retrofit. The paper that Jenna and I, that we've written is actually a challenge to the community and data providers and others to start thinking about ways to stop retrofitting and do it more purposefully. So our knowledge starting points are that we know vulnerability, knowledge about climate and health often excludes older adults in particular, or doesn't consider aging processes. mechanisms are knowledge about potential exposures is kind of getting to be well understood, but not how or why exposure matters. And then frameworks are usually around climate and health, or health and aging, or aging and health, or environment, health and aging, but rarely climate, health and aging. And so that also, as a consequence, the data are, the spatial and temporal resolutions of the available data sets are often incomplete, and retrofitting has to happen rather than a purposeful fitting. So if you're using a longitudinal or a panel data set, there's probably nothing whatsoever in that data set about climate, for example. So you might use like, the health and retirement study, and almost nothing about whether somebody was actually had an actual exposure to a disaster or a climate event.
As I will be trying to figure out in my dissertation.
Exactly. So, so the knowledge is really siloed. This is, so you have these intersections of health and climate. The themes there are very much, a lot of what we know is about heat as a climate factor, and about thermoregulation. And so themes there might be on how thermoregulation breaks down, for example, over time, and also on infectious disease. Like we can expect more dengue, for example, as a result of the various changes in the habitat for the dengue carrying mosquitoes and so on. Within the intersection of aging and climate, we have often we understand biophysical vulnerabilities, and again, air quality has been and temperature have been the key themes that have been paid attention to, rather than the consequences of populations to aging populations in response to disasters, disaster preparedness, disaster response, and so forth. And then on health and aging, a lot of studies on the global trends of aging and chronic conditions and sociocultural variations, but again, not a great pairing with the climate. So those knowledge bases are siloed, and there are starting points. And let's see. Switch. Okay, so I'm going to switch to Jenna. She'll take it from here.
Yeah. So why is this important? Well, older adults are vulnerable to climate-related stressors in a variety of ways. We'll touch on some of these. These vulnerabilities span many dimensions, including from the biophysical, the socioeconomic and cultural, and intersecting with equity dimensions. Also, many of these vulnerabilities occur throughout the life course. Our attention is to focus on ages above 65 and the aging population, while noting that these cumulative processes also need study. So we have published this paper, and this is, we'll show you the paper version of the framework next, but here's our little animated version of it. So thinking about how climate change impacts health outcomes in the context of aging. We have climate change, we think about long-term change, we think about those trends that Deborah mentioned before of warmer temperatures, precipitation changes, some areas getting wetter, some areas getting drier. Seeing flooding and sea level rise, especially in low-lying coastal areas, as well as some of these extreme events. So storms, fires and particulate matter, air pollution, repeated exposures and compound events, what happens when some of these things happen together, and thinking about the various health outcomes and how do we get from climate change to impacting health outcomes. So we first think about some of the biophysical vulnerabilities, thinking about thermoregulation, chronic conditions, nutrition, some of the socioeconomic and cultural vulnerabilities, poverty, social isolation, living arrangements, risk perception, and behavioral change, all of which can be influenced by in an older population. And then also thinking about equity, so how these things intersect with race and ethnicity, thinking about older adults of color, for example, migration, immigrant folks, incarceration, sexuality and gender, and the urban-rural continuum. So we we propose these specific mechanisms for causal pathways that are things that will need study. And we also want to consider the spatial and temporal scales, as Deborah mentioned, because oftentimes a lot of these data are not compatible and sometimes have to be retrofitted for you to be able to study them. And also thinking about changing geography and events. So here's the framework that was published in the paper. Very similar as you
Just less colorful.
just less colorful. They change it. So thinking about some key knowledge gaps. In terms of mechanisms, most of our knowledge, as Deborah mentioned, is drawing on exposure to heat, but there are many different types of climate hazards, such as what mechanisms are important for moderating air pollution due to wildfire exposure or flooding or sea level rise. Sometimes the biophysical research is not well connected with social mechanisms. We also have many populations that are historically understudied in general, but specifically with regard to older populations. This lack of knowledge is amplified in studies of climate impact. So thinking about older adults who may have cognitive impairments and Alzheimer's and other related dementias, those populations may be just inherently challenging to study because of their, for example, lack of ability to communicate. So they may be harder to reach via surveys, for example. Immigrants, especially people without legal status or language of destination capacity, also older LGBTQ plus adults as well. And then we also have some knowledge gaps around long-term climate change. So our current knowledge base in terms of climate change is largely focused on understanding some of the impacts of disasters, but many of these studies that look at disasters look at one disaster individually. Like, so for example, a study will look at Hurricane Katrina or Hurricane Sandy, but not really looking at the overall impact of disasters in a systemic way. We see that some work has been done on understanding future exposures to heat and sea level rise, but again, mostly not with older adults as a focus specifically. And then also some important processes like migration and other family demographic outcomes, such as living arrangements and caregiving, are not well understood in this context. So thinking about data and measurement, these vulnerabilities span many dimensions, but does our data collection capture those many aspects? So thinking about, for example, in surveys, some surveys that are nationally representative do not ask about climate change. There are some that we will talk about today that recently added a question. But what does it mean to add questions? Sometimes you have respondent fatigue to consider in some of these surveys. Also, many of these processes that we talked about occur throughout the life course. We have some panel data that are being collected on health outcomes. We have, for example, the health and retirement study that follows older adults longitudinally, but may not have specific questions on some of these things. So the health and retirement study is one, the NLSY and the PSID are other examples of longitudinal study data, but they don't cover the entire life course either. So we have some next steps and suggestions for research, and I'm going to pass it back to Deborah.
So we have these in several different bins, and if you're interested in this area, these are the challenges that we open up to the community of researchers. So if you're an aging researcher or a health researcher and you want to be thinking about these topics in the context of climate change, we encourage you to like reach out to your data provider, for example. So these are just like our way of like some top themes that we have here. And but this is largely in this, a lot of this is in the supplement. And these are just examples, but for studies that aren't primarily focused on older adults, if we want to understand older adults in these nationally representative surveys, we probably need to oversample them, for example. The data collection should consider other challenges related to older adults, such as issues of dementia and isolation. And we might want to include or develop key risk factors such as social isolation, things that we expect to be increasing with age. We also strongly, climate is a spatial, occurs spatially. So all data sets should be now adopting meaningful geocoding principles to foster data integration where necessary, so that, you know, if you have a survey that doesn't ask about this stuff, you could at least pair it with heat data if you know something about, or precip data, for example, if you know something about the location. I mean, the more meaningful the geocoding, the better, even if that requires working in a data enclave. One should consider resolution and meaningful aggregations or downscalings when using data sets or preparing them. And we strongly recommend oversampling climate stress regions. Like we have, this is not such a hard thing to do, or at least doing something that allows for a post enumeration sort of stratification that could be done, that allows us, like if we wanted to understand population trends or aging and health trends in drought-prone regions or hurricane-prone regions. You know, we know something about, like, let's look at the desert Southwest. Let's look at Florida if we're just talking about the U.S. Or like definitely look at India for drought conditions globally. And so oversampling these regions, or at least using statistical techniques to get representative in those regions so we can meaningfully consider some of the disaster and climate change profiles, would be really important. And this is just something this is an area we have a lot of expertise in our epi-biostats, social science community, and we're really kind of being laggards, if you ask me about that. So we want to respond rapidly. So sometimes prepare for rapid implementation in a post-disaster setting, of course, not impeding disaster work, but you know, when appropriate thereafter. Also partnership between data collectors and relief workers. And there's also something about capturing, you know, there's a lot of information during a post-disaster work that's important to capture. And there's a kind of a burgeoning field of researchers looking at that. And also utilize alternative forms of data collection sometimes in that process. Finally, looking ahead, like longitudinal studies can really help ascribe causation. And so, you know, we should not remain stuck in continuous cross sections if necessary. Ongoing data collection can assess long-term trends and impacts, and then integrate new technologies. Not a hard thing to give a survey respondent a cheap little indoor air quality, temperature, humidity measurement, you know, device that collects that data and could be used. So you could look at the indoor, you know, we can say something about outdoor heat, but outdoor heat and indoor heat are often very different, for example. So these kinds of, and some of these technologies are really cheap. So these are just a few ideas. This is not an exhaustive list. It's just an example of the things that pretty much is not covered now, and we, you know, as a starting point for thinking about next steps for the research infrastructure. As I mentioned, I'm going to mention the NPCC, the New York City Panel on Climate Change, in a moment. But in addition to that, there's now a new virtual center called the Center on Climate and Aging, Climate and Health, CASH. And it's recently funded by the National Institutes of Aging, and it's funded by Colorado and CUNY. We're lead on it, and then with our colleagues at University of Minnesota, University of Washington, and El Colegio de Mexico. And this is a place for sharing code largely and sharing training materials, because no institution has it all. And it's also to build and engage an interdisciplinary and collaborative research community, and some pilot projects are there. So that's what's available there. And our third co-author on this paper is Lori Hunter, who is the co-MPI on that. And then the New York City Panel on Climate Change. So Jenna and I had the good fortune of working together on the health chapter. The fourth assessment chapter is on health. The fourth assessment has a chapter on health, and we were working on that chapter. And, you know, as we were working on it, there was really little, there was a lot of attention to the disease ecology and little attention to the fact that New York, just like aging populations. And so, you know, people think of New York as a young and vibrant city, not as a city of potential future aging. And it is. And in fact, there's a pretty vibrant community of people interested in the aging and the healthy aging of New Yorkers. And so we tried hard to sort of get those, you know, get a little bit of that framing into that. So the interesting thing about NPCC is it brings together researchers, city agencies, and community stakeholders. And if you're interested in what an assessment is rather than a research project, I encourage you to go to the assessment website. You can also find the peer-reviewed publications there, plus brief summaries that are available in about 15 different languages that for anybody in the to read. So, and then the data are also shareable there. Uh-oh, I don't know what I did.
I don't know. Did either.
No signals. Oh, no, there we're back. Okay, so we're transitioning now from that framework. So that framework was a lot of fun to write. So it was the first time I've written a paper without data in a very long time. And it was really a lot of fun to think about those issues. But now we're going to talk about a couple empirical examples, all that are in various stages. I'm going to talk about a very local example, and then 2 national examples. These are all using individual level data that have full age distributions. I'm going to show them in order of like project age from the most mature to the newest. I'll talk about 2 of them, and Jenna will talk about 1 of them, and 2 of them involve Jenna as well, but the first one is a project that doesn't. But the important thing is, and these are all a little in the retrofit area, but they're trying to get at aspects that are newer than, cover some territory, some new territory. And importantly, most of this work is very descriptive, but the idea here is it helps to set the stage for more causal work, because one of the big issues in using some of these panel data sets is they're a little underpowered potentially, given the when you retrofit them to a climate phenomena. So the first data set, and I just want to, the team of people here includes my colleague Frank Hyland at Baruch, Selin Ozdogan as an economist, Ph.D. doctoral student at the grad center, myself, Jennifer Bright, who has her Ph.D. from this very school and is a faculty member at York College, and Peter Marcatulio at CUNY Hunter College in geography. So, and you'll see this, we've put the teams up for all of these things. The point of us showing the teams is there's a student co-author in all of these things. There are many different institutions. Sometimes this one's all CUNY, but very often they're not all CUNY. And they also, this is all within the social and health sciences, but all the other ones also have some physical science folks on it too. And that's just the nature of this work. So I just thought it was useful to highlight that. The objectives of this particular study were to examine the connections between weather extremes and persons buried in the nation's largest indigent burial ground, Hart Island. Can't quite see that from our window here, which is in the Bronx. I'm sure all of you are familiar with it as that New York City has a public burial ground. It's the nation's largest and oldest. There are more than 1 million unclaimed individuals have been buried there. It provides, the public burial records provide a window into mortality among particularly vulnerable populations. And what we do with this is we link daily air and wet bulb temperature patterns for the period of 1977 to 2022 to daily death data that remain unclaimed and subsequently were buried on Hart Island. And it's the first of its kind. Just very briefly, the unclaimed deaths, this is what the data look like. On the left-hand side, you see from in the period of study, the blue height is males, the orangish bars are females, and then the gray are unknown deaths, unknown gender ascribed to them. And you see COVID popping out, and in the 80s, you see that's largely the result of HIV. And then we also see on the right-hand side, we see the number of unclaimed deaths by month. And it, from this, it looks like there's some increase in the winter deaths. And so that just, that's the distribution that we start with. This is gender and just the number of deaths by age. So women are more likely to be women buried on Hart Island are on average older than men, but men of course make up the bulk of the indigent burial deaths. This is what the temperature variation looks like for those of you who are unfamiliar with temperature data. On the right-hand side, we see the air temperature data for seasonal variation. We see fall, the red are the maxima and the blue are the minima. So we see that, New York has 4 very distinct seasons and that they're all increasing over time. So these differences may not look like a lot, but they are, in fact, we've had the hottest, the several past years have broken one hot record after another for average temperatures. We can see the, for a single year, 2015, on the right-hand side, we see the annual minima and maxima temperatures. So for the, So just to get to the effects of what we find, so we pair these data because it's just all, we take a single estimate of the temperature for the city rather than anything spatial, and all the deaths occur in one place on Hart Island. We don't take, we do know in this data set where people are, where the place of death is, but in this particular analysis, we're not accounting for that. And the estimated effect is of a 10 Fahrenheit increase in extreme temperatures in summer leads to, increases, it leads to an additional unclaimed death count. And you can see it on the image on the right-hand side, that's the red bar. And then the other interesting thing is controlling for max and extremes at the other end of the scale. The minimums are generally not predictive of mortality in summer or winter, but there's some evidence of this in the fall, where the same 10 Fahrenheit increase in the fall mins are associated with roughly 0.4% fewer deaths. So, and we can imagine what the mechanisms could be for that. It could be, people are the longer it takes to get, the warmer the minimums are, the minimums are, the more likely people can, live with, like people who might be energy insecure, don't have to turn their heat on, or people who might be, have a lot of, we have some street homeless in this population and it's still warmer out and so on. And so, so those are two possible mechanisms for these kind of phenomena, for that result. And this is a graphical version basically of this. This is showing the 7-day max temperatures. And just to know where to ask the question of where age fits in, since we do have single year of age, the main effect persists by under and over 65, but importantly, the average age of the Hart Island death differs by gender. So the impact we see among older ages is really an effect occurring more so to women. Yep.
What's the Y?
On this, the Y is, they're odds of, or no, it's not odds. I think it's just death rates. It's the increase in the marginal effects of death, the death rates. So I'm just going to go to the blue line here, which is, in addition to these magnitudes of effects, we find that the further analysis, when we compare this to citywide rates, we find that 5% of all extreme heat-related deaths were unclaimed in New York City, implying that those who died due to extreme heat were more than 3 times as likely to be buried on Hart Island. So that's a pretty significant result, just in terms of magnitude, and suggesting that this research highlights the undue burden that climate places on really vulnerable populations. People who are buried on Hart Island are there because they either can't afford a burial or have no family to claim them. And so we argue that like this kind of a window into this aspect of vulnerability, it's innovative, but bringing these demographic and climate change data to look at to capture and understand these impacts, but it's just a starting point. To the deeply vulnerable are really hard to study. So this is one attempt at it. So if you're interested, there's a paper coming out in Social Science and Medicine that looks at these data sets broadly in the US, and or that link takes you to a poster of that effect. So so now, we still have, we tried to get rid of our
animation,
but we have no idea. It was like random animation, AI animation. So the second, the little analysis underway is looking at disaster displacement. And we're working with an engineering student, and Jenna, and again, Frank Hyland and myself. And in this case, we're asking the question, how do individuals and families respond to natural disasters? So this is the question that we ultimately hope to look at with like NLSY and HRS, but we're not there yet. We're just taking taking this pulse data set, the household pulse data set,
the Census Bureau,
which the Census Bureau produces. I'm going to tell you about that in a minute, but there's like little evidence on this very particular question. A lot of the questions about disasters always goes to migration. Ergo, this analysis is an example, but the more general question is how do families double up? Does somebody go collect their older adult relative and bring them to their home that's farther away from a coastal zone when a big hurricane is coming? Those are the kinds of questions. Or are people anticipating these effects, you know, and so on and so forth? Do you move your healthcare provision in advance of these storms so you can continue dialysis, for example? Anyway, these are the kinds of things that like are of interest to ask. So we have like a tiny little window into some of this, which is by using the new nationally representative pulse survey, which asks one and only one direct question about in response to a disaster, to examine this across some basic demographic and health outcomes. So it just helps to set the benchmark. So the question, the household pulse survey, it's an experimental survey from the Census Bureau. It began during COVID to ask some questions about COVID. There are truly a limited number of questions, like 20 questions are asked. It's a high frequency, short turnaround instrument. It's internet only. It was questions about displacement due to natural disaster were added in 2022 in the very end of that year. And they are still asked now. So we have roughly 2 full years of they're asked, and they asked, were you displaced in the last year? And there's absolutely no other climate exposure or responses asked. They ask if you do say you're displaced, they ask for how long and a couple other follow-up, but very basic questions. So, and then they do this post-stratification weighting to ensure national representativeness of the population over age 18 living in housing units, not living in institutional settings. So, okay, so that's, so the question, so the next set of questions asks about disasters, hurricanes. This is the question that it includes, such as hurricanes, floods, and fires in the past year. Were you displaced from your home because of a natural disaster? That's the specific question. What type of natural disaster, mark all that apply, and people can list hurricane, flood, fire, tornado, or other. And then they recategorize it. There's also one that says multiple, but they don't tell you what combinations of multiple. Our best guess is it's hurricane and floods together, but this is our inference from the results. How long were you displaced? And then these damage and so forth. And then in the first month after a disaster, what did you experience? Shortage of food, shortage of drinking water, loss of electricity. We have yet to look at any of those other questions. But what we've looked at so far, they collect information on age, race, ethnicity, and children under age 18, some limited socioeconomic stuff, and contemporaneous issues like, have you lost employment in the last 4 weeks? So you might have been displaced 9 months ago, but it asks about loss of wages or employment in the last 4 weeks. And then similarly, anxiety or depression, mental health treatments, and disability, again, in the current period. What do we know from this? So we've learned that in the past year, that is until September 24, so it's roughly, I think,
January to September.
Yeah, this is actually only 9 months of the 2024 cycle, roughly, 1.2% of the population over age 18 reports being displaced. And, you know, that sounds like a small percentage, but that's a lot of people. And 27 were displaced due to hurricane. That's the light green bar, and 18% were displaced from multiple disasters. That's the dark blue bar. And this is just the total population. So then we can say, well, let's take a look further. When we learn that displacement's really not very evenly distributed, like hands down on the left-hand side, you see people who said they weren't displaced. On the right-hand side there, you see people who said they were displaced. All racial groups except whites have been disproportionately displaced compared to their white counterparts. People of Hispanic origin have twice the odds. Blacks have 2.6 times the odds. Asians have 1.4, and people who responded that they were of other or multi-race, non-Hispanic, had 2.2 the odds of whites. So kind of unambiguous, whites are least impacted in terms of displacement. Furthermore, as these pies show the type of disaster, and non-Hispanic whites were displaced most by hurricanes and least by multiple disasters, and whereas Hispanics are most likely displaced by hurricanes and multiple disasters. And that's kind of important because, that's probably Florida. And so we'll learn a little bit more about that. So displacement by age. Here we see that young adults, not older adults, And those up to age 64 have a little bit higher odds of getting displaced compared to those over 65. And this may be partly because persons over 65 have, they just don't want to move in a disaster. It's harder to, even they want to hold their ground. And you see some anecdotal evidence of this. They're also more impacted by flooding in particular. So flooding causes movement. And importantly, adults 65 are most likely to be displaced by hurricanes, about 30% of their displacements as compared to about 6% of those under 65. Again, probably a Florida effect. So what can we learn from this? Well, broad strokes, and it's a broad strokes and nationally scoped review. It has some shortcomings, like potentially helpful for contextualizing panel data observations or those with risk exposure, but not actual individual level disaster impact, right? So it's really hard to get actual disaster impact. I can't state that clearly enough. Disaster impact might be a continuum where displacement is super blunt instrument. So that's unfortunate that they didn't ask about, like, did you lose electricity? Did you have food spoilage? Did you have other kinds of things? Did you, or how does this impact your thinking about moving in general? Those kinds of questions. Our older and of course, older adults are probably less likely to answer internet surveys, despite the claim of the post-stratification work here. The next step is to do more with multivariate analysis, considering some of the questions about duration and quality of impact among those who were displaced, look at disaster displacement with contemporaneous disability. And finally, it's worth mentioning that this particular survey, the Household Pulse Survey, is turning into a panel. So we wanted to understand it before they go into the panel mode. And then once it's a panel mode, we can look at actually some other behaviors that change over time, which we think will be actually really valuable. We're glad the census is doing that. We had the census decided to do that without consulting us. But I think it's a really important and by the way, for anybody who teaches, these data sets are the data sets are made available like within a couple weeks. Weeks after the collection of the data. And they make tables available as well as the micro data. So depending upon what level statistics type course you're teaching, or it's a great use of look into some of these data sets. Okay, I'm going to let Jenna's going to wrap us up with the most complicated and newest of the data sets that we're looking at.
Sure. So we're talking now about a project that was developed for a hack week at the University of Washington called Disasters, Disparities, Displacement, and Decisions. And it was organized by the University of Washington and NOAA. We formed a team across 3 institutions. So CUNY, Arizona State, and the University of Colorado. We have Deborah, who's a demographer, Dylan, who's a spatial scientist, Melanie, who is a hazards geographer, Lori, a sociologist, myself, public health, and Helen, who is an environmental scientist. And our goal is to understand the burden of hazards on the U.S. population in the past decade and what implications it might have for risk mitigation and emergency preparedness. So thinking about who's disproportionately exposed to hazards. Prior studies tend to be hazard specific. So either looking at a specific hurricane, like we mentioned previously, place specific, so looking at a specific area such as a state or city, or rely on aggregated data, which raises issues in terms of an ecological fallacy. And then also prior studies also tend to focus on disasters with presidential, like FEMA declarations only. And we're going to integrate use of a data set that has additional information about disaster exposure. So again, we're thinking about how does exposure differ by hazard? How have these rates of exposure changed over time? Which are maybe some questions we haven't quite gotten to yet, but we can talk about ways that we might address those in future analyses. And also thinking about this population-wide study to set the stage for future paddle studies. So our data sources that we're using are the 30 million observations on the individual and household level from the American Community Survey, which are not aggregated counts, but actually full information on individuals within what are called PUMAs, public use microdata areas. In New York City, for reference, a PUMA is about the size of a city council district or a community board. In other areas, a PUMA could be much larger, and we'll show some examples of that. And by using this individual level data, we can do analyses that avoid ecological fallacy because we're able to look at associations and cross tabulations on the individual level. We are also incorporating this county level disaster damage and fatality data from the SHIELDIS database, the Spatial Hazards, Events, and Losses database for the United States, of which Melanie Gall, who is on our team, is the administrator on. So thinking about integrating the SHIELDIS data and the American Community Survey, well, first we need a temporal linkage. So thinking about how to make these two work, we decided to make our exposure data in year T linked to population characteristics in year T-1. So in this presentation, I'll show you some examples of 2012 population and 2013 exposure, or 2020 population and 2021 exposure, for example. And looking at this map, our SHIELDIS data is county level. So this is the state of Washington, where we went to work on this project together. And each of these gray shades represents a county. The PUMA level are these red boundaries. So you can see that for certain counties, the PUMA consists of 2 counties. In more urban areas, like closer to the SeaTac area, Seattle and Tacoma, there are much smaller boundaries. And the state is the yellow outline, and both these counties and these PUMAs are constrained to states. So it was kind of a challenge to think about how to fit those together because those do not fit perfectly. We also had some challenges and some choices to make about exposure. So the SHIELDIS dataset records monthly exposures and at the county level. So collecting data on type of disaster, amount of damage, damage per population, the money about the crop loss as well as data on fatalities. And just looking at the database as a whole, about 90% of the population is exposed to any hazard in any year. So therefore, we decided to apply a threshold, and specifically FEMA's 2022 countywide indicator threshold, which is about $4.10 per person in terms of damage. And we had to think about how we can combine some of these things. So thinking about creating a cumulative measure that incorporates loss of property, crop, and life. So we apply this standard from FEMA of that threshold, and we also apply the FEMA standard to value of statistical life. So every life lost is given a value, and that is used to calculate how much damage financially the event caused, and then that allowed us to say, okay, does this event meet this threshold? If so, we're considering it as part of our exposure. If not, we're not considering it as part of our exposure. So here are some descriptive graphs looking at the exposure rates by age category by census division. So each one of these facets of this graph represents a different census division, and the different colored lines represent racial and ethnic groups. The x-axis on each of these graphs represents age distributions, and the y-axis represents exposure rates. So basically this is saying what percent of the population of a specific racial and ethnic group in a region was exposed in this 2013 year based on the population that was living there in 2012. And we see that, and I'll show you another year of the same type of graph, we can see that there are some racial disparities, and we are also seeing some trends. The Florida effect, as we were mentioning earlier, likely is going on. We're seeing, for example, in 2012, we think there maybe was a hurricane that could have hit, for example, South Florida, which is why we may be seeing some of these higher rates in Hispanic people in this region, for example. But in all, between these two different years, you see that the variation in exposure is quite different between the 2 years in each region. And looking at years or times in which there were higher exposures, there tend to be higher rates of disparity than when there are lower rates of exposures. But again, these are still very exploratory descriptive analyses. And because of the microdata that we have, we're hoping to be able to move into some predictive modeling. So here's another example of the level of detail that this microdata on the individual level allows us to give. These are population pyramids that show the distribution of people across the country by race and ethnicity, by age, by gender, by mobility difficulty. So people respond in the American Community Survey whether they have difficulty with mobility. They say yes or no. And we would expect and do see that as age increases, we see a higher share of the population with these difficulties. And we do see some disparities in those proportions by race and ethnicity. And our next kind of steps are to kind of think how to link these.
What are those plots called?
These are called population pyramids. They're very commonly used in demography, which I have a certificate. Yeah.
So, I mean, I love this plot just in a descriptive sense because like, sure, okay, American Indian and Alaska Natives are not a large share of the population, but here we basically see a representation of the entire population, right? This is a 1 in 10 sample from the Puma microdata, so it's intended to be representative of the entire population of American Indians and Alaska Natives. And we see, of course, greater disparities. We see the age distribution in like older adults, but in this population, you don't have to, that group F is not the oldest adults. Those are people in under 65. It's a very large group. But we see the disparities, like the relative size of the red bars to the blue bars are, I think, really telling amongst these population groups. Like you see larger shares of red to blue among the non-Hispanic, Black, and African American, and the American Indian and Native, Alaska Natives, kind of hands down in this graph. So again, straight description, but
Is this difficult that you have these spikes at the bottom and at the top?
Yeah, so that's part because we have uneven age groups. Group B, Group B is a larger group, like it's age 5 to 17, and Group F is 45 to 64. We decided to do some of these age groupings. We do have single year age. We decided to do some of these age groupings for like life stage thoughts, like thinking about children, thinking about young adults, thinking about people in middle age, up to older age, and then the oldest age group. But typically when you see a population pyramid, it's a bit smoother.
Yeah, but that's it, and it's usually done for 5 years, sometimes
for 5 year or single year age
or single year age groups. And it's almost always imbalanced at the top between men and women, men on the left and women on the right.
Yeah,
males and females are always divided that way. That's that's a standard.
Oh no, what happened? Okay, we're back, I think.
So is that saying that there was a baby boom?
Yep.
Where
in
these two
baby booms are, this is exactly, well, I mean, I wouldn't, because of the uneven size of the groups, we can't really see a baby boom here, but if you like just look at, population pyramid, 1980 US, you will definitely see the baby boom right there, like very clearly. This is exactly the storytelling that goes on with this kind of device.
The other thing you can see is like the relative age of the population. Like you see that the white group has a higher proportion of older adults and a smaller proportion of younger adults compared to Hispanic, for example, which is like a demographic group that has higher rates of fertility. So they have more younger people relatively.
And life expectancy.
And life expectancy is also higher
in whites than non-whites.
Right.
So,
yeah,
for the most part.
I love learning about a new type of plot.
No, great. Population pyramids we love them. They're very, very useful description. It's also always a good starting point because it forces you to understand the composition that before you so whether you need to like decompose something.
Yeah, so our next kind of steps are thinking about how we can take that level of demographic detail that we have and use it to assess disparities in exposure to disasters. And so here's an example of just like 1 year again. But thinking about what we can learn from the study overall, and this is, I believe, our last slide. Hopefully we can learn a lot. But this study is quite new, quite young. The data set is huge. We not only have 30 million observations, but we're looking over multiple years. And in addition to that, to be able to link the data from pumas to counties, we have to sometimes duplicate or triplicate or quadruplicate people. If a puma, it contains multiple counties because we don't know where people are, which county people live in. So we construct a weight so that that person is sometimes divided probabilistically. So actually looking at even 1 year is sometimes 10 million observations. And the full analysis has been requiring a supercomputer to run, which we're fortunate to have an access to that resource. So that's been very helpful. But again, is another reason that we're still in some of the preliminary stages of this. But we are seeing some regional and race ethnicity patterns at this first look. We're noticing that the regional exposures may depend on hazard type, which is not something that we've begun to talk about here. With these data, we also have the ability to look at some of these higher exposure states. So we could look at just Florida, for example, because we have such a large sample size. And ultimately, we're hoping to examine whether there are demographic shifts in exposure. So most prior research is showing people moving towards rather than away from exposed regions, which maybe is not the most productive means of adaptation to climate change, but those are the patterns that we're seeing currently. It'll be interesting to see how those patterns shift in the future and or even in the present on data that's being collected presently. And then also, we're hoping that this project is setting the ground for future usages of microdata rather than aggregates in climate vulnerability studies. Like we mentioned, a lot of studies are looking at aggregate census level data because that's the best kind of data you have to go along with your exposure data. So,
Or most easy to use.
or the most easy to use.
Yeah. I mean, geographers tend not to be geographers tend to be more trained in use of aggregate data than microdata, for example. So
that is our presentation.
Yeah.
Thank you for joining us.
Yeah, sorry.
We have one audience member.
Oh my God, I didn't realize it was in person.
Great.
Probably not the only person here watching from the office.
Do we have any questions?
Yeah, happy to.
I see Sophia made a question about the data getting thinner when you use yearly segments. Absolutely.
Totally.
Yeah.
I have like an overall response that's not,